So, my dear student, today we will be discussing about the chlorine. So here, first one is preparation. So here, chlorine can be prepared by heating hydrogen chloride with manganese dioxide. So here, chlorine can be prepared by heating hydrogen chloride with manganese dioxide. So here, formation of chlorine along with manganese chloride, So next, laboratory method. Next one, laboratory method. So here, chlorine can be prepared by heating sodium chloride with concentrated H2SO4 in presence of manganese dioxide. So here, formation of chlorine along with sodium hydrogen sulfate and manganese chloride So here, chlorine can be prepared by heating sodium chloride with concentrated H2SO4 in presence of manganese oxide. So here, formation of chlorine along with manganese chloride and sodium hydrogen sulfate. So here, this chlorine can be also prepared by heating hydrogen chloride with potassium permanganate, So here, formation of chlorine along with KCl, manganese chloride, and water. So here, chlorine can be prepared by heating concentrated hydrochloric acid with potassium permanganate. So formation of chlorine along with KCl, manganese chloride and water. So here, this is about the preparation of chlorine by laboratory method. So next, we move towards the manufacture of chlorine. So here, chlorine can be manufactured on large scale by oxidizing hydrogen chloride by atmospheric oxygen at 723 Kelvin in presence of cupric chloride. So here, chlorine can be manufactured on large scale by oxidizing hydrogen chloride by atmospheric oxygen at 723 Kelvin in presence of cupric chloride. So here, formation of chlorine take place in large scale. So here, chlorine can be manufactured on large scale by oxidizing hydrochloric acid by atmospheric oxygen at 723 Kelvin in presence of cupric chloride. We get chlorine on large scale. So next one is by electrolytic process. So next one, electrolytic process. So here already we know that what you mean by electrolytic process. So here consider beaker which containing two electron. So here this beaker containing drain solution or saturated solution of sodium chloride. So here the external electric current is passed into two electrode. So here chlorine is liberated at anode and sodium is liberated at cathode. So here at anode chlorine is liberated at cathode sodium is liberated. So here this sodium react with water to form sodium hydroxide. So here electrolytic process, consider beaker containing drain solution. Drain solution means saturated solution of NaCl. Two electrodes are immersed in it, the passing electrical current. So here chlorine is liberated at anode and sodium is liberated at cathode. So here at anode chlorine is liberated. So here formation of chlorine takes place, and at anode sodium is liberated, and this sodium is reacted with water to form sodium hydroxide. So this is about the manufacture of chlorine. So next we move towards the physical property of chlorine. So here first one, chlorine is greenish yellow gas with pungent odor. It is greenish yellow gas with pungent odor. Second one, it liquefies to greenish yellow liquid and it is soluble in water. So first one is chlorine is greenish yellow gas with pungent odor. Second one, it can be liquefied. To greenish yellow liquid and it is soluble in water. So next we move towards the chemical property. First one, reaction with metal and non-metals. First one, reaction with metals and non-metals. So here chlorine react with number of metals and non-metals to form corresponding chlorides. So consider Al, it is react with chlorine, formation of AlCl3. Similarly 2 mole of sodium react with chlorine, so formation of sodium chloride. So here phosphorus react with chlorine, so formation of phosphorus trichloride. Sulfur, it is react with chlorine, formation of sulfur monochloride. So this is about the reaction with metals and non-metals. So here chlorine react with metal and non-metals to form corresponding chlorides. So here first one is react with metal. So here chlorine react with Al, so formation of AlCl3. So here chlorine react with sodium, so formation of sodium chloride. So here next one is reaction with non-metal. Chlorine react with phosphorus to form phosphorus trichloride. Similarly, chlorine react with sulfur to form sulfur monochloride. chloride. So here second one is reactivity with or towards hydrogen. Second one, reactivity with hydrogen or reactivity towards hydrogen. So here chlorine have great affinity. Chlorine has great affinity for hydrogen, hence it reacts with compound containing hydrogen to form HCl. So here formation of 2 mole of HCl. Similarly, hydrogen sulfide react with chlorine, formation of hydrogen chloride with sulfur. So here chlorine has great affinity for hydrogen, hence it react with hydrogen containing compound to form HCl. Similarly, C10H16 react with chlorine, react with 8 mole of chlorine. So formation of HCl along with 10 carbon. So second one is reactivity with hydrogen or reactive towards hydrogen. So chlorine has great affinity for hydrogen. So ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೈತಿ ಕ್ಲೋರಿನ್ ಯಾವ ಕಂಪೌಂಡ್ ಹೈಡ್ರೋಜನ್ ಇರ್ತಿರಲ್ಲ ಅದ್ರ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ಏನು ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತೈತಪ್ಪ ಅಂದ್ರೆ ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತೈತಿ. ಸೊ ಮೊದಲನೇ ರಿಯಾಕ್ಷನ್ ಕ್ಲೋರಿನ್ ಇಂದ ಹೈಡ್ರೋಜನ್ ಕಂಬೈನ್ ಆಯ್ತಪ್ಪ ಅಂದ್ರೆ ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತೈತಿ. ಕ್ಲೋರಿನ್ ಇದ್ದು ಹೈಡ್ರೋಜನ್ ಸಲ್ಫೈಡ್ ಫಾರ್ಮೇಷನ್ ಆಯ್ತಪ್ಪ ಅಂದ್ರೆ hydrogen chloride formation activity with sulfur. So similarly, C10H16 it is combined with chlorine. So formation of 16 mole of HCl along with 10 mole of carbon. Chemical properties reaction with ammonia. So here excess of ammonia react with chlorine. Excess of ammonia react with chlorine to form 6 mole of ammonium chloride with nitrogen. So here excess of ammonia react with chlorine to liberate nitrogen along with 6 mole of ammonium chloride. Second one, excess of chlorine react with ammonia. Excess of chlorine react with ammonia to form nitrogen trichloride with HCl. So no, third one is reaction with ammonia. So ಇಲ್ಲಿ ammonia ಜಾಸ್ತಿ ಇತ್ತು, excess of ammonia. So chlorine ಜೊತೆ react ಆಯ್ತಪ್ಪ ಅಂದ್ರೆ ನಮಗೆ ಏನು ಲಿಬರೇಷನ್ ಆಕತಿ, ನೈಟ್ರೋಜನ್ ಗ್ಯಾಸ್ ಲಿಬರೇಷನ್ ಆಕತಿ. ಸೊ ನೈಟ್ರೋಜನ್ ಗ್ಯಾಸ್ ಜೊತೆ ನಮಗೆ ಏನು ಫಾರ್ಮೇಷನ್ ಆಕತಿ, ಅಮೋನಿಯಂ ಕ್ಲೋರೈಡ್ ಫಾರ್ಮೇಷನ್ ಆಕತಿ. ಯಾವಾಗ ಫಾರ್ಮೇಷನ್ ಆಕೈತಪ್ಪ ಅಂತಂದ್ರೆ ನಾವು excess of ammonia ತಗೊಂಡಿರ್ತೀವಿ. So second one, if we take excess of chlorine, ಕ್ಲೋರಿನ್ ಜಾಸ್ತಿ ತಗೊಂಡಿದ್ದಪ್ಪ ಅಂತಂದ್ರೆ ಅವಾಗ ಅಮೋನಿಯಾ ರಿಯಾಕ್ಟ್ ಆಯ್ತಪ್ಪ ಅಂದ್ರೆ ನಮಗೆ ಫಾರ್ಮೇಷನ್ ಆಕತಿ, ನೈಟ್ರೋಜನ್ ಟ್ರೈಕ್ಲೋರೈಡ್ ಫಾರ್ಮೇಷನ್ ಆಕತಿ along with HCl. So this is about the reaction with ammonia. So next one is reaction with alkali. So here chlorine react with cold dilute alkali like sodium hydroxide to form mixture of sodium chloride with sodium hypochlorite. So here chlorine react with cold dilute sodium hydroxide. Cold dilute sodium hydroxide, formation of mixture that is sodium chloride with sodium hypochlorite along with water. So here chlorine react with cold dilute sodium hydroxide, formation of mixture that is sodium chloride with sodium hypochlorite along with water. Second one, chlorine react with hot concentrated sodium hydroxide. Chlorine react with hot concentrated sodium hydroxide to form 5 mole of sodium chloride, 5 mole of sodium chloride along with sodium chloride, along with sodium chloride. So here chlorine react with hot concentrated sodium hydroxide. So formation of sodium chloride along with sodium chloride, along with sodium chloride. So here fourth one is reaction with alkali. So nodri chlorine ಏನು ಮಾಡ್ತೈತಿ cold dilute sodium hydroxide react ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ ನಮಗೆ ಮಿಕ್ಸ್ಚರ್ ಕೊಡ್ತೈತಿ. ಎಂತದ ಮಿಕ್ಸ್ಚರ್ ಕೊಡ್ತೈತಿ? ಒಂದೇದು ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್, ಇನ್ನೊಂದು ಸೋಡಿಯಂ ಹೈಪೋಕ್ಲೋರೈಡ್ ದ ಮಿಕ್ಸ್ಚರ್ ಕೊಡ್ತೈತಿ. ಹೌದಾ? ಅದೇ ರೀತಿ ಕ್ಲೋರಿನ್ ಹಾಟ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಎನರ್ಜಿ ರಿಯಾಕ್ಟ್ ಆಯಿತು ಅಂತಂದ್ರೆ ನಮಗೆ ಅವಾಗ ಏನು ಕೊಡ್ತೈತಿ? ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ along with sodium chloride, along with sodium chloride. So this is about the reaction with alcohol. Next chemical property is reaction with dry slag lime. So here slag lime means nothing but calcium hydroxide. So here chlorine react with dry slag lime, that is calcium hydroxide form calcium oxychloride along with calcium chloride, So here chlorine react with calcium hydroxide, form calcium oxychloride along with calcium chloride. So this is about the reaction with dry slag lime. So next one, sixth one, reaction with hydrocarbon. Hydrocarbon. So here chlorine react with hydrocarbon to give substrate product with saturated hydrocarbon and addition product with unsaturated hydrocarbon. So here consider example methane. It is react with chlorine, formation of methyl chloride along with HCl. Similarly C2H4 react with chlorine at room temperature. We get 1,2-dichloroethane. So here chlorine react with hydrocarbon to give substrate product with saturated hydrocarbon and addition product with unsaturated hydrocarbon. So now sixth one ಏನಾಗೈತಪ್ಪ ಅಂದ್ರೆ reaction with hydrocarbon. Chlorine hydrocarbon react ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ substitution product ಕೊಡ್ತೈತಿ. Fifth one, reaction with dry slacked line. So here slacked line means nothing but calcium hydroxide. So here calcium hydroxide react with chlorine. Calcium hydroxide react with chlorine to form calcium oxychloride along with calcium chloride. So here calcium hydroxide react with chlorine to form calcium oxychloride along with calcium chloride. So here this is about the reaction with dry slacked line. So next, sixth one, reaction with hydrocarbon. Reaction with hydrocarbons. So here chlorine react with hydrocarbon to give substitution product with saturated hydrocarbon and addition product with unsaturated hydrocarbon. So consider example CH4. It is treated with chlorine, formation of methyl chloride with HCl. So here hydrocarbon react with chlorine to form substitution product with saturated hydrocarbon So second example, C2H4 react with chlorine to form 1,2-dichloroethane. So here chlorine react with hydrocarbon to give addition product with unsaturated hydrocarbon. So here this is about the reaction with hydrocarbons. So next we move towards the oxidizing nature. So here the chlorine is dissolved in water. The solution is slowly decomposed to form HCl and HOCl. So here this HOCl is known as hypochlorous acid. This HOCl known as hypochlorous acid. This hypochlorous acid, it is unstable and it slowly decomposes to give HCl and nascent oxygen. On account of formation of nascent oxygen, chlorine is act as oxidizing agent as well as bleaching agent. So ನೋಡಿ chlorine water ದಾಗೆ ಏನಾಗೈತಿ dissolve ಆಗೈತಿ. So dissolve ಆಗಿ ಪಾತ್ ಏನಾಗೈತಿ slowly decompose ಆಗೈತಿ. So decompose ನಮಗೆ ಏನು ಫಾರ್ಮೇಷನ್ ಆಗೈತಿ hydrochloric acid. HCl ಫಾರ್ಮೇಷನ್ ಆಗೈತಿ. ಇನ್ನೊಂದು ಏನು ಫಾರ್ಮೇಷನ್ ಆಗೈತಿ HOCl. HOCl ಅಂತಂದ್ರೆ hypochlorous acid. So here this hypochlorous acid ಏನಿದೆ unstable ಐತಿ. So unstable ಇರೋದ್ರಿಂದ slowly decompose ಆಗಿ ನಮಗೆ ಏನು ಫಾರ್ಮೇಷನ್ ಆಗೈತಿ HCl ಫಾರ್ಮೇಷನ್ ಆಗೈತಿ. ಅದರ ಜೊತೆಗೆ nascent oxygen ಫಾರ್ಮೇಷನ್ ಆಗೈತಿ. So nascent oxygen ಫಾರ್ಮೇಷನ್ ಆಗೋದ್ರಿಂದ ಕ್ಲೋರಿನ್ ಏನು ಕರಿಬಹುದಪ್ಪ ಅಂದ್ರೆ oxidizing agent as well as bleaching agent. So consider example. First one, chlorine oxidize sulfite to sulfate. So first example, chlorine oxidize sulfite to sulfate. So here sodium sulfite is react with chlorine, formation of Na2SO4 sodium sulfate with 2 mole of HCl. So here conversion of sulfite into sulfate. So next, second example, chlorine oxidize, chlorine oxidize ferrous sulfate into ferric sulfate. Ferric sulfate. So here chlorine is oxidized, acidified, chlorine is oxidized, acidified ferrous sulfate into ferric sulfate. So here this ferrous sulfate or acidified ferrous sulfate, it is treated with chlorine, formation of ferric sulfate with HCl. So here chlorine, it oxidized, acidified ferrous sulfate into ferric sulfate. Similarly, third one, chlorine oxidize sulfur dioxide into sulfuric acid. So here sulfur dioxide, it is treated with chlorine, so formation of H2SO4 with 2 mole of HCl. So here chlorine oxidized sulfur dioxide into sulfuric acid. So here this is about the oxidizing nature of chlorine. Next we move towards the bleaching action of chlorine. So here chlorine, it acts as bleaching agent with moisture. Chlorine, it acts as bleaching agent with moisture. It bleaches vegetables, organic matter, wood pulp and fabrics. The bleaching nature is by oxidation. The bleaching nature of chlorine by oxidation. So here this is about the bleaching action. So next we move towards the uses of chlorine. First one, chlorine, it is used as bleaching agent. Chlorine, it is used as bleaching agent for cotton fabrics, and paper industries. Second one, chlorine is used for manufacture of dyes, drug and some other organic compound like CCl4, carbon tetrachloride, DDT. So next, third one, chlorine is used for preparation of poisonous gas like poison, COCl2, and tear gas, formula CCl3NO2. So here these are the uses of chlorine. So here first one is chlorine is used as bleaching agent for cotton fabrics and paper industries. So second one, chlorine is used for the manufacture of dyes, drug and some organic compounds like carbon tetrachloride and DDT. So here chlorine is also used in the preparation of poisonous gas like poison, formula COCl2, formula COCl2, and tear gas, formula CCl3NO2. So here these are the uses of chlorine. Next we move towards the hydrogen chloride. So first preparation by laboratory method. First one, laboratory method. So here HCl is prepared by heating sodium chloride with concentrated H2SO4. So here HCl can be prepared by heating sodium chloride with concentrated H2SO4 at 420 Kelvin to form HCl along with sodium hydrogen sulfate. Sodium hydrogen sulfate. So here this sodium hydrogen sulfate again is heated with NaCl at 823 Kelvin to form HCl along with sodium sulfate. So here this is the preparation of HCl by laboratory method. So nodri first ನಾವು ಏನು ಮಾಡ್ತೇವಪ್ಪ ಅಂತಂದ್ರೆ NaCl ನ ಹೀಟ್ ಮಾಡ್ತೇವೆ. ಅದರ ಜೊತೆಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ H2SO4 ಟೆಂಪರೇಚರ್ ಎಷ್ಟಿರುತ್ತೆ 420 ಕೆಲ್ವಿನ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲ. ಅವಾಗ ನಮಗೆ ಏನು ಫಾರ್ಮೇಷನ್ ಆಕತಿ HCl ಫಾರ್ಮೇಷನ್ ಆಕತಿ. ಅದರ ಜೊತೆಗೆ ಸೋಡಿಯಂ ಹೈಡ್ರೋಜನ್ ಸಲ್ಫೇಟ್ ಫಾರ್ಮೇಷನ್ ಆಕತಿ. ಸೊ ಸೆಕೆಂಡ್ ಒಳಗ ಸೋಡಿಯಂ ಹೈಡ್ರೋಜನ್ ಸಲ್ಫೇಟ್ ನ ಮತ್ತೆ ನಾವು ಏನು ಮಾಡ್ತೇವೆ ಹೀಟ್ ಮಾಡ್ತೇವೆ. ಅದರ ಜೊತೆಗೆ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಜೊತೆಗೆ ಟೆಂಪರೇಚರ್ ಎಷ್ಟಿರುತ್ತೆ 823 ಕೆಲ್ವಿನ್. ಅವಾಗ ನಮಗೆ ಏನು ಫಾರ್ಮೇಷನ್ ಆಕತಿ HCl ಪ್ಲಸ್ sodium sulfate formation again. So here next we move towards the physical properties. Physical properties. So first physical property is HCl. It is colorless and pungent smelling gas. So first physical property, HCl is colorless and pungent smelling gas. Second one, it can be easily liquefied. It can be easily liquefied to colorless liquid. To colorless liquid and freezes to crystalline solid. Freezes to crystalline solid. Second one, it can be easily liquefied to colorless liquid and freezes to crystalline solid. Third one, HCl, it react with water or dissolves in water to form H3O plus and Cl minus. So here first property is it is colorless pungent smelling gas. Second one, it can be easily liquefied to colorless liquid and freezes to crystalline solid. Third one, HCl, it react with water or HCl, it dissolves in water to form H3O plus and Cl minus. So here this is about the physical properties of HCl. Next we move towards the chemical properties of HCl. So first one is acidic nature. First one, acidic nature. So here HCl ionizes in aqueous solution. HCl ionizes in aqueous solution to form H3O plus and Cl minus. Higher the value of dissociation constant of HCl, it indicates HCl is stronger acid in aqueous solution. So here HCl is strong monobasic acid. So here HCl, it ionizes in aqueous solution to form H3O plus and Cl minus. So here, higher the value of dissociation constant of HCl, it indicates HCl is stronger acid in aqueous solution. Therefore, HCl is strong monobasic acid because HCl it ionizes, gives H plus and Cl minus. So here dissociation of only one H plus ion, therefore this is called as monobasic acid. So next chemical property is reaction with ammonia. So here HCl react with ammonia to form 5 fumes of ammonium chloride. So here HCl react with ammonia to form 5 fumes of ammonium chloride. So next, third chemical property, reaction with salt of weak acid. So here hydrogen chloride decomposes salt of weak acids like carbonate, hydrogen carbonate and sulfides. So consider reaction sodium carbonate react with HCl to give 2 mole of sodium chloride with water and carbon dioxide. So here HCl it decomposes salt of weak acids like carbonates, bicarbonates and sulfides. So consider first example, sodium carbonate. It is treated with HCl to give sodium chloride along with water and carbon dioxide. So next one is sodium bicarbonate react with HCl to form NaCl along with water and carbon dioxide. So here next one, sodium sulfide react with HCl to form 2 mole of NaCl along with water and sulfur dioxide. So ಏನಪ್ಪಾ ಅಂದ್ರೆ reaction with salt of weak acid. HCl ಏನು ಮಾಡ್ತೈತಿ, salt of weak acid ಜೊತೆ react ಮಾಡ್ತೈತಿ. Okay, salt of weak acids ಯಾವು, carbonates, bicarbonates and sulfides. So ಮೊದಲ reaction ಒಳಗೆ ಐತಿ HCl ಇದ್ದು ಕಾರ್ಬೋನೇಟ್ ರಿಯಾಕ್ಟ್ ಆಗೈತಿ. ಯಾವ ಕಾರ್ಬೋನೇಟ್, ಸೋಡಿಯಂ ಕಾರ್ಬೋನೇಟ್ ರಿಯಾಕ್ಟ್ ಆಯ್ತು ಅಂದ್ರೆ ನಮಗೆ ಫಾರ್ಮೇಷನ್ ಆಗ್ತೈತಿ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತೈತಿ, ಅದ್ರ ಜೊತೆಗೆ ವಾಟರ್ ಅಂಡ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್. Similarly, HCl it is react with sodium hydrogen carbonate, sodium bicarbonate. So here formation of NaCl, water with carbon dioxide. Similarly, HCl ಮತ್ತೆ react ಆಗತೈತಿ, ಇದನ್ನ decompose ಮಾಡ್ತೈತಿ salt of sulfide. Sulfide ಯಾವ್ದಿಲ್ಲಿ, sodium sulfide. It is react with HCl to form NaCl along with sulfur dioxide and water. So here this is about the chemical properties of hydrogen chloride. Next we move towards the uses of hydrogen chloride. So here first one is hydrogen chloride is used for manufacture of chlorine, ammonium chloride and glucose. So here hydrogen chloride it is used to manufacture chlorine, ammonium chloride and glucose. Second one, this hydrogen chloride it is used for extracting glue from bone. So here HCl, it is used for extracting glue from bone. Third one, this hydrogen chloride, it is used manufacture of medicine and laboratory reagents. So here first one is hydrogen chloride edike use ಮಾಡ್ತಾರೋ ಅಂತಂದ್ರೆ ಒಂದನೇದ್ದು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಮಾಡೋದು. ಅದನ್ನ ಕ್ಲೋರಿನ್, ಅಮೋನಿಯಂ ಕ್ಲೋರೈಡ್ ಮತ್ತು ಗ್ಲೂಕೋಸ್ ಅನ್ನು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಮಾಡಬೇಕಂದ್ರೆ ನಾವು ಏನು ಯೂಸ್ ಮಾಡ್ತೇವೆ? ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೇವೆ. ಸೊ ಸೆಕೆಂಡ್ ರೀತಿ ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ edike ಯೂಸ್ ಮಾಡ್ತೇವಪ್ಪ ಅಂತಂದ್ರೆ ಎಕ್ಸ್ಟ್ರಾಕ್ಟಿಂಗ್ ಆಫ್ ಗ್ಲೂ ಫ್ರಮ್ ಬೋನ್ ಆಗಿರ್ತಕ್ಕಂಥ ಜಿಗಿಟ್ ಪದಾರ್ಥ ಅಂಟನ್ನ ತೆಗಿಬೇಕಂದ್ರೆ ನಾವು ಯೂಸ್ ಮಾಡ್ತೇವೆ ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೇವೆ. ಥರ್ಡ್ ಪಾಯಿಂಟ್, ಇಟ್ ಈಸ್ ಯೂಸ್ಡ್ manufacture of medicines and laboratory reagents. So here this is about the uses of hydrogen chloride. We move towards the oxoacids of halogens. So here fluorine can form only one type of oxoacid, that is HFO. So this is known as fluoric acid or hypofluorous acid because fluorine exhibits high electronegativity and smaller size. Therefore, fluorine can form only one type of oxoacids. But other halogens forms 4 series of acids with the formula HXO, HXO2, HXO3, HXO4. So here these are stable in aqueous solution. So consider some structures of oxoacids of chlorine. So first one is hypochlorous acid. The formula is HOCl. So here structure ClOH containing 3 lone pair of electrons. Second one, chlorous acid. Chlorous acid. So formula HClO2. So structure is ClOH double bond O containing 2 lone pair of electron. So next, third one, chloric acid. Formula HClO3. So structure is ClOH containing 2 double bond O with 1 lone pair of electron. So next, fourth one, perchloric acid. So formula HClO4. So structure is ClOH containing 3 Cl double bond O. So here this is about the oxoacids of halogen. So here fluorine can form only one type of oxoacids. So fluorine ಏನು ಮಾಡ್ತೈತಿ? ಒಂದೇ type of oxoacids ನ formation ಮಾಡ್ತೈತಿ. ಅದು ಯಾವಪ್ಪ ಅಂತಂದ್ರೆ HOF, fluoric acid or hypofluorous acid. ಸೊ ಇದು ಒಂದೇ ಟೈಪ್ ಆಫ್ ಆಕ್ಸೋ ಅಸಿಡ್ಸ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತೈತೆ ಅಂತಂದ್ರೆ ಇಟ್ ಹ್ಯಾವಿಂಗ್ ಹೈ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಅಂಡ್ ಸ್ಮಾಲರ್ ಸೈಜ್. ಫ್ಲೋರಿನ್ ಇದ್ದು ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಸ್ಮಾಲರ್ ಸೈಜ್ ಇರೋದ್ರಿಂದ ಫ್ಲೋರಿನ್ ಏನ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತೈತಿ, ಓನ್ಲಿ ಒಂದೇ ಟೈಪ್ ಆಫ್ ಆಕ್ಸೋ ಅಸಿಡ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತೈತಿ. ಬಟ್ ಅದರ್ ಹ್ಯಾಲೋಜನ್ಸ್ can form 4 series of acids with formula. So other halogens ಏನ್ ಮಾಡ್ತಾವು, 4 series of acids ಅನ್ನ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವು. ಫಾರ್ಮುಲಾ ಏನೈತ್ರಿ, HXO, HXO2, HXO3, HXO4. Okay, so next one, some structure of oxoacids of chlorine. ಕೆಲವು ಸ್ಟ್ರಕ್ಚರ್ ಬರೆದ್ರು. ಸ್ಟ್ರಕ್ಚರ್ ಎದಪ್ಪ ಅಂತಂದ್ರೆ ಆಕ್ಸೋ ಅಸಿಡ್ಸ್ ಆಫ್ ಕ್ಲೋರಿನ್. ಸೊ ಮೊದಲೇ ಆಕ್ಸೋ ಅಸಿಡ್ಸ್ ಯಾವಪ್ಪ ಅಂದ್ರೆ ಹೈಪೋಕ್ಲೋರಸ್ ಅಸಿಡ್, ಫಾರ್ಮುಲಾ HOCl. ಸೊ ಸ್ಟ್ರಕ್ಚರ್ Cl containing OH 3 lone pair of electron. So next, chlorous acid, formula HClO2. So Cl is bonded with 1 OH and 1 Cl double bond O with 2 lone pair of electron. So third one, chloric acid, formula HClO3. So here Cl is bonded with 1 OH and 2 double bond O and 1 lone pair of electron. So next, fourth one, perchloric acid, formula HClO4. So in this structure, Cl is bonded with 1 OH bond and 3 Cl double bond O. So here this is about the oxoacids of halogen.